Hello and welcome to Escape Velocity Space News. I am your host, Dr. Pamela Gay, and I am here to put science in your brain and to warn you that the second week of July is going to have way too many things going on. Non-Patreon viewers are going to get this episode, which I'm recording June 26th on July 3rd. And our next episode, the first episode of Season 3, is going to reach you July 17th. Patrons, you get everything about 5 days earlier. Right now, it's looking like all the following things could happen in that 3-week window. Starliner could come home with Butch and Suni. Polaris Dawn could fly with their private crew on July 12th and try to conduct the first spacewalk by non-space agency-related crew. Chandrayaan-3 might have taken off on July 14th. Right now, we don't know if these things will happen, but we know they could happen. And I'm already planning to film shorts for Instagram and other short video platforms, so I can keep you up to date on what is going on during this pre-planned and apparently ill-timed gap between our seasons. Like, we're only taking 1 week off. This is kind of nuts. If you want to follow along with us, we'll be streaming watch parties on Twitch, posting videos wherever the tech will let us, all under the username CosmoQuestX. That's our parent organization. And heck, give CosmoQuestX a follow and find out about all the things we do other than EVSN. Until then, we get to spend today catching up on Percy rover, looking at black holes behaving like stars, and we follow along as the JWST changes our perspective on the interstellar medium. And of course, we've got the latest news from the launch pad. All this and more is coming to you right here, right now on EVSN, a product of CosmoQuest. And we are supported through our Patreon at patreon.com/CosmoQuestX. I have a ton of black hole related news. But before I get to any of that, I want to take a moment to look in on Perseverance Rover. The Mars Perseverance Rover has been making its way along the coastline of a long dried up river that once allowed water to drain from Jezero Crater. Today, the Noritov Vallis River Channel isn't just dry, it's filled with sand dunes. And sand dunes are known to be rover-eating monsters. Rather than plunging into the channel and risking a crossing where the dunes were too big, the rover has been painstakingly picking its way around boulders and hoping to find a gently sloping shoreline into a region with much less dramatic dunes. This tedious process has been slow, with the rover only making it 30 meters or so at a time. Lately, mission planners have been concerned the rover would get behind schedule on its scientific explorations. But that all changed in early June when Percy found safe passage down into the riverbed and found its way through the dunes. In a single day, it leapt forward 200 meters to a pile of interesting rocks in the center of the channel. Since then, it has continued to wheel forward 100-meter-ish bursts at a time, allowing the rover to catch up to its planned schedule while taking time to check out amazing rocks that are like nothing we have seen before on Mars. Personally, I'm just in love with this image that shows a Mars river made of dunes and little Percy's remarkable path of exploration. Here's to hoping there are more of these great strides forward and fewer boulder fields in the rover's future. One of the great rules of astronomy is that the same rules of physics we see here on Earth in our corner of the universe are the same rules of physics that control all of space and time. Mostly. Some forces only work on tiny scales, so at the atomic level, it feels like things are working differently. In the very first tiniest fraction of a second in the universe, the forces were all one force, but they split apart faster than an atom can oscillate. In general, it's the same physics all the way out. And this leads to some really cool realities. Consider for a moment the modest ball of incandescent gas that is a star. As suns form, they all start out as a giant clump of gas and dust that collapses for some reason and transforms into a flattened disk with a concentrated core of a future star in the center. These cores and disks can even generate magnetic fields, powerful winds, and amazing jets. This transformation is governed by basic things like the conservation of momentum, gravity, electromagnetism, and thermodynamics. And there is no reason for the smallest stars and maybe even rogue planets to form any differently from how the largest stars out there form. And now it's appearing that there is also no reason for black holes to form any differently. In a new paper with lead author Mark Gorski in the journal Astronomy and Astrophysics, researchers demonstrate that the supermassive black hole in the core of ESO 320-G020 is in some ways just like one of those solar nebulae. Located just 120 million light years from Earth, this active galaxy is currently host to clouds of infalling gas that are working their way in toward the black hole. According to researcher Susanna Alto, quote, "We can see how the winds form a spiraling structure billowing out from the galaxy's center. When we measured the rotation, mass, and velocity of the material flowing outwards, we were surprised to find that we could rule out many explanations for the power of the wind, star formation, for example. Instead, the flow outwards may be powered by the inflow of gas and seems to be held together by a magnetic field." This is remarkably like what we see in star formation, and Gorski goes on to explain, quote, "In our observations, we see clear evidence of a rotating wind that helps regulate the growth of the galaxy's central black hole. Now that we know what to look for, the next step is to find out how common a phenomenon this is." End quote. Well, it's awesome to finally be getting a handle on just what's going on in some galaxies' black hole-filled cores. We still have one giant problem. We don't really understand how the black holes got there. Once upon a time, in that simpler universe we could imagine before we got all of JWST's pesky data, we theorized that early galaxies were small with small black holes, and we'd be able to see things build larger and larger over the first billion years or so of galaxy formation. And then we got to actually see galaxies in the first billion years. Lots of them. And those galaxy supermassive black holes somehow have already reached 10 billion solar masses in these early times. As a new paper in Nature Astronomy with first author Sarah Bozeman points out, this requires something radical to have happened in the early universe. I can't explain it any better than Bozeman, so I'm going to read you her words. Quote, "Overall, the new observations only add to the mystery. Early quasars were shockingly normal. No matter in which wavelength we observe them, quasars are nearly identical at all epochs of the universe. Not only the supermassive black holes themselves, but also their feeding mechanisms were apparently already completely mature when the universe was a mere 5% of its current age. By ruling out a number of alternative solutions, the results strongly support the idea that supermassive black holes started out with considerable masses from the get-go. In astronomy lingo, that they are primordial or seeded large. Supermassive black holes did not form from the remnants of early stars, then grow massive very fast. They must have formed early with initial masses of at least 100,000 solar masses, presumably via the collapse of massive early clouds of gas." End quote. This again brings us to that idea of black holes forming like stars. Only in this case, we have some process we didn't expect, perhaps even forming while our universe was still an ionized mess of nuclei before the cosmic microwave background even formed. This is a radical idea. But none of our old ideas fit the data. So getting radical is going to be required. I can't wait to see just how quickly theories will fly and our field can find some explanation for the universe we now see. For now, though, it's time for a break. Up next, we look at JWST's new perspective on interstellar dust bunnies. Stand by. The interstellar medium is not my favorite topic in astronomy. Fundamentally, it is the study of interstellar dust bunnies, those clumps of gas and dust that clog up our skies and block our ability to see more distant stars and galaxies. They don't vary like the pulsating stars I love most. They don't have stories that alter how we understand our universe, like galaxies and galaxy clusters. The gas and dust between stars, it's just transient blobs of material, sometimes bright and sometimes dark, that are either released during stellar death or waiting to form new stellar life. The thing is, infrared telescopes like the JWST are changing how we see the interstellar medium. In these longer wavelengths of light, formerly opaque clouds are now semi-transparent regions, and what was once just a hole in the sky can now be seen as interesting star-forming regions or vibrant locations rich in never-before-seen dynamics. Regions that were once just bright blobs are now getting resolved into individual stars that are as active as the active galactic nuclei I love, just at much smaller scales. In this closer look, we're going to look at some of our new views on the sky, revealed by our new IR views on nebulae. Theorists have long stated through math and computer simulations that a collapsing cloud of gas and dust should spin up and transfer its momentum to its fragmenting solar nebulae, that in turn form aligned young stars. This isn't to say an entire star-forming region has totally aligned stars. That's not true. Rather, one small collapsing region will fragment into co-aligned individual stars. It all makes sense. We've been saying it for years, but we didn't have evidence this was true until now. Thanks to the JWST, researchers now have the resolution to see if this theory works. And researchers looking at the star-forming region, Serpens Main, have identified a region with 20 candidate protostellar outflows that all seem to be the same age and also aligned to within plus or minus 24 degrees. They estimate the probability of this randomly occurring is 1 in 10,000. This alignment isn't chance. This is science. Serpens Main is a star-forming region that is just 1 to 2 million years old, and it is just one of many star-forming regions JWST is peering into. Deep in the Rho Ophiuchus star-forming region is a long-studied knot of star formation cataloged as WL20. The young stars are only 2 to 4 million years old, and detailed images of this system can be used to better understand star formation. Only it turns out that one of those stars we've been studying is actually 2 stars. In optical telescopes, these stars are entirely hidden by opaque gas and dust. But in prior IR images, it looked like 2 hotter stars and 1 cooler star. The new JWST mid-infrared instrument images reveal the cooler star, WL20S, is actually 2 stars that each have hints of stellar jets. This work was presented by Mary Barsoni at the American Astronomical Society meeting. She notes, quote, "After studying this source for decades, we thought we knew it pretty well. But without Mary, we would not have known this was 2 stars or that these jets existed. That's really astonishing. It's like having brand new eyes." End quote. Leveraging their JWST discoveries, the team went on to get Atacama Large millimeter and submillimeter observations that were more sensitive to the light coming from the stellar jets. The combined data shows WL20S is a pair of stars with aligned disks and aligned jets, a binary star system forming together just as theory always said we should see. As an astronomer, I look at the resulting images and am in awe at the details. But one remarkable illustrator took the science image and translated it into an illustration that beautifully rendered everything to make what's going on clear to anyone. JWST's ability to show us new things spans from what is cosmically in our backyard and all the way out to the most distant corners of our universe. Consider, for instance, the galaxy SPT 0615-JD1. That's its catalog number. We shouldn't be allowed to name things. This early system shines its light from when the universe was just 460 million years old. It was first discovered as a streak of light in a Hubble Space Telescope image, just another gravitationally lensed object that has its light magnified and distorted by the gravity of a massive galaxy cluster. With JWST's higher resolution and larger light gathering capacity, HST's smudge resolved into numerous knots of light. This work appeared in a new paper in Nature led by Angela Adamo. She explains, quote, "The surprise and astonishment was incredible when we opened the Webb images for the first time. We saw a little chain of bright dots mirrored from one side to the other. These cosmic gems are star clusters. Without Webb, we would not have known we were looking at star clusters in such a young galaxy." End quote. These systems are consistent with them being protoglobular clusters, star systems that are gravitationally bound together and that will experience just one burst of star formation and then travel through history together as an aging family of stars. We know from looking at nearby globular clusters that these are systems formed early in the universe, but we hadn't realized previously what an important role they played. Adamo further explains, quote, "These results provide direct evidence that indicates protoglobular clusters formed in faint galaxies during the reionization era, which contributes to our understanding of how these galaxies have succeeded in reionizing the universe." End quote. The early universe cooled from an early state of hot, fully ionized gas to cool neutral gas. Neutral gas can't generally be seen through, and we know that at some point in history, ultraviolet light from hot stars ionized the neutral gas, making our universe transparent. One of the justifications for building JWST was to try and directly observe this process. These images are just the starting point in this team's research. Next, they look forward to looking at this system with JWST's spectrometer. This will confirm the system's distance and allow them to get additional insights on the system's physical properties and star formation rates. And when the results are out, we'll bring them to you right here on EVSN. Today, we've focused on star-forming regions. We could just as easily have talked about the beautiful chaos of gas and dust that are shaped by stellar death. JWST's latest image of the Crab Nebula, for instance, is allowing astronomers to see details that honestly leave us just that much more in awe of this amazing structure. It was originally thought that the supernova that went off in 1054 might have been a rare electron capture supernova. The idea that the one supernova that was both super nearby and, as far as supernovae go, fairly recent, happened to be a rare kind of supernova, that hasn't sat well with us. We like to think we don't exist in a special time or place, and just like I can't count on winning the lotto to solve my funding issues, we can't count on rare events to occur where they are easy to study. Sure, I might win the lotto, and a rare supernova might go off cosmically nearby. It's just unlikely. And with the new JWST data, the nebula not only looks better than we've ever seen it, we are also finding that its data is completely consistent with it being a totally normal core collapse supernova that was caused by a large star filling its nucleus with iron before going boom. It probably was a star on the small side as far as the range of truly massive exploding stars goes, but it was likely just a normal event occurring as they do. And with more data, we should gain a deeper understanding of not just nebulae, but so many other things as well. In the next few years, we're going to start seeing some of the world's next generation telescopes, systems with mirrors tens of meters across, begin to make observations. These new systems and the new advanced optics that are getting installed on systems like the Large Binocular Telescope are going to allow us to get images as clear as Hubble's, or better, with the kinds of sensitivities Hubble's small mirror never allowed. We are on the edge of something amazing. It's just going to be amazing with the side of communications satellites. But the problems with Starlink, OneWeb, and other mega constellations polluting ground-based astronomical images is a story for another day. For now, we're going to take a break and then come back with this week's news from the launch pad. Stay tuned. Next up, I'm pleased to welcome on aerospace correspondent Erik Madaus for this week's Tales from the Launch Pad. Hey, Erik.
Hi, Pamela. Not much happened in the last 2 weeks. Let's get on with the show. On June 8th, Virgin Galactic launched the Galactic 07 suborbital tourist flight on the VSS Unity spaceplane from Spaceport America in New Mexico. On board were 2 pilots and 4 space tourists, including Tuva Atasever, the second Turkish government astronaut. He was a backup mission specialist for Axiom Mission 3. 5 of the 6 people on board, including the pilot, were performing their first spaceflights. Unity took off under the VMS Eve mothership and was released at 1526 UTC, landing about 15 minutes later, following a flight to a 90-kilometer apogee. This was the 10th and final spaceflight for VSS Unity, which is being retired for the cheaper and easier to build Delta class of spaceships. On June 20th, Rocket Lab launched the No Time to Loose mission from their second pad at the New Zealand spaceport. On board were 5 satellites for French IoT company Kinesis. Let's watch the launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. Beginning pitch over.
Stage 1.
We are on our way to space. Our 50th Electron rocket has taken flight and is headed to orbit carrying 5 satellites for Kinesis.
This launch marked Rocket Lab's 50th launch and also the fastest any rocket has made it to 50 launches, beating out SpaceX's Falcon 9 by several months. 3 of those launches have ended in failure. Also on June 20th, SpaceX launched the SAS-24 Astra 1P satellite on a Falcon 9 rocket from Slick 40 at Cape Canaveral. Let's watch the launch.
5, 4, 3, 2, 1. Ignition. And liftoff. Go SpaceX, go Astra 1P. Mission downrange.
SES-24 will deliver direct-to-home broadcast television across Europe. It's an all-electric propulsion satellite and will be in service for at least 15 years. The Falcon 9's first stage successfully landed for its 9th time on the Just Read the Instructions drone ship. There were also 3 Starlink launches in the last 2 weeks.
Thanks, Erik. Now, I'm going to let all of you out in the audience in on a little secret. I recorded 2 days after Erik. This means I can add that a SpaceX Falcon Heavy successfully launched the GOES-U weather satellite on June 25th, and we'll be covering this in detail in our next episode. We track launches with the help of RocketLaunch.live. As of today, June 26th, so far this year there have been 123 launch attempts. We track launches by location, and there have been 71 U.S. launches, 28 Chinese launches, 7 launches from New Zealand, 4 launches each from Kazakhstan and Russia, 2 launches each from India, Iran, and Japan, and 1 launch by North Korea. Of these launches, there were 3 failures, reminding us that space is hard. Before we go, I'd like to update you on a story from last month. On May 20th, an X-12 solar flare pummeled Mars with high-energy light and particles, causing both aurorae we could detect with the MAVEN mission orbiting Mars, as well as static flickers in Mars Curiosity's normally pristine images. The Mars Curiosity rover's radiation assessment detector measured a radiation dose of 8,100 micrograys, which is the equivalent of 30 chest x-rays. It won't kill you, it's just a lot. This was the highest radiation burst Curiosity has so far measured, but it was most likely not the highest blast Mars has recently received. Back in 2003, 2 solar maxes ago, the Sun unleashed a massive X-45 flare in the direction of Mars. This event grazed our world, sending astronauts into their more protective capsules and many satellites into safe mode. If they were lucky. A few didn't make it. A lot of satellites actually died from this and other flares that fateful October. We're not exactly sure how much radiation hit Mars, but we do know it was enough to destroy the Martian radiation environment experiment on board Mars Odyssey. Designed specifically to measure solar activity, this is the one time I feel engineers failed to over-engineer for what our solar system can throw at these missions. While I, as a sometimes selfish landscape photographer, desperately want our planet to get zotted by an X-45 so I can photograph the aftermath of aurorae, that 2003 storm was a lesson that not all satellites and instruments would survive that magnificent of an event. And as our current economy needs satellites, the more empathetic astronomer in me understands that kind of solar flare would be a very bad thing. Heck, that X-12 that hit Mars would probably have been a fairly bad thing here. Solar Max was originally predicted for July 2025. Given the rise in sunspot numbers, some researchers estimate it could come early. But we probably still have many more months before the sun becomes most active as its magnetic field hits that midpoint in its reversal. Once that happens, it should begin its slow 6.5-year journey to solar minimum. And that's it for now. Good night, everyone, and remember to go out and look up. Oh, and please give this video a like and subscribe so you find out when our next episode comes out, and hopefully the algorithm gives more people more science. Thanks.